All right, today we're going to talk about surface area and volume of prisms and pyramids. The formula we're going to be using for finding the volume of a prism is simply the area of the base multiplied by the depth of that prism. So first one, find the volume of the following shapes. Well, this one here, we have what appears to be a triangle connected by a rectangle. So the area of the base of a triangle is base times height divided by 2. Or in this case, the base is 2.1, the height is 2.1 divided by 2, which gives us an area of 2.2 centimeters squared. So this end here of this triangle, or this triangle area here, is 2.2 centimeters squared. The volume of the prism is the area of the base, which we found to be here, multiplied by the depth. So 2.2 multiplied by the depth, or how deep it goes, 3.2. And that would be equal to 7.04 centimeters cubed. Right? So the first step, we find the area of the base and then multiplying that by the height. Our next example, we have an odd shaped here, but we also have the area given to us. So the volume of the prism is the area of the base multiplied by the depth. The base gives us 5.5, that should be meters squared, multiplied by the height of 10 meters, which gives us 155 meters cubed for the volume of this prism. For example C, we have what looks like kind of an odd shape here and another one here. So if we kind of split this in half, it gives us the measurements here of this trapezoid. So we have 15 meters, and this is 7. From one end to the exact opposite is 9. So that means that from one end to the midway point, or halfway, is 4.5. So I just simply drew it out like this. We have 4.5 distance here, and then 7, and this is 15. So the area of a trapezoid is equal to one side length plus another side length multiplied by the height divided by 2. So it would be 7 plus 15, 7 plus 15 multiplied by the height. In this case, this is our height of the trapezoid, right? One side length, another side length, the height of it, divided by 2. So then we have the area of this trapezoid here is equal to 49.5 meters squared. Now, that's just 1/2, right? So there's actually another half to that. So we'd have 49.5 multiplied by 2, or the base of this, which is this whole piece here, is 49.5 multiplied by 2. We get 99 meters squared. So now that we have the area of the base, 99 meters squared, we can then plug it into our prism formula. Area of the base multiplied by the depth, well, we know it's 99. Our depth is 4.5, and that's indicated over here, so how deep it goes, 4.5, so 99 times 4.5 gives us 445.5 meters cubed. Volume of a square-based pyramid, just a quick kind of formula, rule of thumb, volume of the prism divided by 3. And we know to calculate the volume of the prism to be area of the base multiplied by the depth divided by 3. So we calculate the volume. Here is our prism. So we have side length, and we have this kind of slant area, this slant line. So the area of the base, well, it's 6 and then another 6. 6 times 6, so the area of the base is 36 centimeters squared. Now we don't know the height of it because that would be indicated in the middle here, where I can kind of see that dotted line. But we do have this slant height. Now, if we kind of pencil this in, we do see a right angle triangle. So we'd have, this is the hypotenuse. This distance from one end to the middle is 3. It's half of 6, right? And then from this distance upward is unknown. So we have the hypotenuse squared, which in this case is 10 squared, right? And then we have the height squared, which we don't know, and then the other side length of this right angle triangle that we created to be 3. So performing the math, 10 squared is 100, 3 squared is 9, 8 squared is still unknown. 8 squared is equal to 91, square root both sides. We get the height to be 9.5 centimeters. So now that we have the depth or the height, we can go ahead and start plugging things in. We have our formula, area of the base multiplied by the depth divided by 3, in which case is 36 times 9.5 divided by 3, which gives us a value of 114 centimeters cubed. Third example, a pyramid has a square base length side of 7 meters and a volume of 441 meters cubed. Find the height or the depth of the pyramid. First thing is square base pyramid. It has a side length in its square base. 7 times 7 gives us the area of the base to be 49. So now we have the area of the base. We can go ahead and start figuring out some other things. So area of base times depth divided by 3 is equal to the volume. Now, remember, we don't have the depth. We have the volume, though. So we go ahead and plug in what we do know. We have 441 is equal to 49 times d multiplied by 3. Well, if I go ahead and solve for the variable of d, I end up getting 441 multiplied by 3 gives me 1,323 is equal to 49d. Solve for d, I end up getting 27 is equal to d. Now, I have my depth and I have my area of the base. So the height of the pyramid is 27 meters. I'm just going to skip through here because we don't need to talk about that. Example 4, how would we get the slant height of each of these pyramids? So the slant height is basically this height here. So we have the base and we have one of the edges, but that slant height, how do we calculate that? Well, we have this base length is 24. So we think about drawing that imaginary, I'll pencil it in actually, that imaginary triangle to the middle of the prism, and then we can go ahead and identify pieces of information that are pretty crucial, right? So we have, actually another way we look at it, get rid of all this, is we can see here we have a length, a right angle, a hypotenuse, and an unknown side. So right there we can use a Pythagorean theorem. Well, if this is 24, half of 24 is 12. The other side length we don't know, so that's s squared. And then the hypotenuse length is the length of the triangle across from the right angle, right? So that's 15 squared. So a squared plus b squared equals c squared. We know our values. So 15 squared is 225, 12 squared is 144. We're solving for that slant height. 225 minus 144. S squared is 81, square root both sides. We get a slant height of 9. So this slant height here would be 9. And then on the other side here, this is better visual than the one I was going to draw in. If we can kind of see how they create another 90-degree triangle within the pyramid. So we have, looking for this slant height, we have the height from the base, from the middle of the pyramid all the way to the top, and we know that one side length is 12, so then this must be 6. So 6 squared, 8 squared is equal to our slant height, and we have that written here. 8 squared plus 6 squared is equal to slant height squared. 64 and 36 is equal to 100 squared. Pardon me, 100, which 100 is s squared. Square root both sides, we get 10 of our value for our slant height. And then finding the surface areas, well, we have the area of the base, length times width, which in this case is 24 times 24. So we know the area to be 546. And then the area of a triangle is base times height divided by 2, or in this case, 24 times 9, right? We found that slant height to be 9. Divided by 2 gives us 108. So what that means is that one of these triangles is 108. We have 4 of these triangles, so 180 times 4 gives us 432, right? So now we just found this, we found this, the back side, and then the left side there. So to find the surface area of the entire thing, we have 576 plus 432, which equals 1,008 units squared for that surface area. And the last one we're going to talk about is more of kind of a thinking question here. We have the height of a frustum is 3 centimeters. It was formed by removing the smaller square base pyramid of 1 centimeter from the top. The square base of the pyramid has a side length of 6 centimeters. Find the volume of the frustum, find the surface area of the frustum. The frustum is this piece here, right here, this bottom piece. It almost looks like a box you could sit on because they took the top of this top piece, and then just cut it out. So we're trying to find the area, or pardon me, the volume of the entire thing minus the volume of the small piece at the top. So the volume of the large pyramid is area of the base times depth divided by 3. Well, the area of the base is 6 and 6. We know that. And then the depth, well, it's indicated here. 3 centimeters is the height of the frustum. And then this piece here from that point on is 1. So 1 and 3 would be 4. So 36 times 4 divided by 3 would give us 48 centimeters cubed. So this entire pyramid is 48 centimeters cubed. Now we need to find the volume of the small pyramid, just the piece here at the top. So same approach, area of the base times the depth. Well, 1.5 times 1.5 is 2.25. The depth is 1, that's indicated here, which gives us 0.75 centimeters cubed after we divide it by 3. So the area of the frustum, which is this base part here, minus the top of this triangle, pardon me, the top of this pyramid, is 48, which we found the volume of the whole thing to be, minus 0.75, which is the volume of the top piece, which gives us a volume of 47.25 centimeters cubed. So that's part A. Last part, find the surface area of the frustum. Again, surface area of this bottom piece here, this whole thing. So we need to find a couple things first. We need to find the slant of the large triangle. So we have a slant height is equal to 4 squared plus 3 squared, right? So if I draw that in real quick, where did I get those numbers from? This, and then this slant height coming up to the top. So this would be 3. We know this whole piece to be 4, and this is our slant height. So slant height, which is this, one side length, and then the height we know to be 4. S squared equals 4 squared plus 3 squared. We end up getting a slant length of 5, right? And then the surface area of the large triangle is the base, length times width, which is 36, and then the triangle, base times height divided by 2, 6 times 5 divided by 2 is 15. There are 4 of these big triangles, which would be 60. So the total surface area is 96 centimeters squared. Then we have the slant of the small. So the small slant here, I'll draw it with a different color. Orange kind of works. And then that slant like this. There we are there. So we have 1 squared plus 0.75 squared, which would then give us a slant height of 1.25. The surface area of the small triangle, the base is 2.25 centimeters squared, and so then we have 1.25 times 1.25 divided by 2, 0.78, right? So then our total of the frustum, surface area of the large minus the surface area of the small, 96 centimeters minus 5.38 centimeters is equal to 90.62. And where I got that from is because we had 4 of those sides, right? So you take the area of the large, surface area of the large minus the surface area of the small, we end up getting the full surface area.